Hello, in this video I'm going to be doing an example problem of Hess's law. And Hess's law basically states that if you can have two or more thermonuclear equations, you add them together, the sum of those two equations, the enthalpy sums, should equal that of the overall equation. It'll make more sense as we do it. Right here we've got three equations. Thermonuclear equations. We got the enthalpy right here, and if you add all these up, they will equal this reaction. And what you can do is you can multiply everything by 2, by 3, by half to make it look more like this equation, or you can flip the reactants and the products by putting them on opposite sides of the arrow. But each time you change the equation, you're changing the enthalpy for that equation, or the change in enthalpy. If you, for example, flip it so that the products are on the reactant side and the reactants are on the product side, you then flip the sign, and a negative would turn positive, or a positive would turn negative. If you multiply everything by 2, you also have to multiply the delta H by 2. So, what I usually do is I kind of skim this overall reaction. This is what I want to get to, or have. So if I have BCl3, I see that here we have BCl3 on the product side, here it's on the reactant side. I want to get it so that it's on the product side, so I'm going to have to flip this reaction. But when I look at it, I have two BCl3s, and here I just have one. So not only am I going to have to flip it, but I'm going to have to multiply everything by 2. I'm going to rewrite it because that's really the only way you could do it. So we got H3BO3 is now going to be on the reactant side. It was once a product, plus 3H. Ooh, we're not only flipping it, but we're multiplying it. So there's two of these. Multiplying it by 2. 3 times 2 is 6, so we got 6HCl gas. Those are my products. Now my reactants are going on the product side. We've got 2 BCl3 because I'm multiplying it by 2. Ooh. Two BCl3 plus my 3 times 2 is 6 H2O. I'm just going to cross that out so I don't get it mixed up, but basically what I did was I flipped it. So these products are now on the reactant side, and I multiplied each by 2. So I got 2 and 6. And these reactants are now on the product side, and I multiplied them by 2, so I've got 2 and 6. But what I did was I flipped it, and I multiplied it by 2. So instead of having a negative, I now have a positive, and I'm multiplying it by 2. Take my calculator out that I bring to class each day. 112.5 times 2 is same thing as 225. 225 kilojoules. I'm just going to cross that out. I've got 225 kJ. Alright. Looking at the next one, I got B2H6 on the reactant side, B2H6 on the reactant side. So it looks like I want to keep that. It looks great. So let's see if we can cancel some stuff out. You can cancel things out if they are found on the reactant side and on the product side. So here we've got 6H2O on the product side. Here 6H2O is on the reactant side. So I'm going to cross that out. Cancel each other out. See if there's anything else. Well, we got 2H3BO3 product side, 2H3BO3 reactant side. I can cross that out. And looking at HCl, maybe we could cross that out because I don't see it. Actually, I do. I see it right there. It's on the product side. Here it's on the reactant side. But then I have HCl here. Try to find something that isn't in here so we can try to get rid of it. So H2, I don't see H2 in this reaction. I've got 6H2 right there, so I'm going to try to cancel that out. Here I have half of H2. Might be a good idea to try to get that bumped up to be 6 so I can cancel out my 6H2. Everything else might just fall into play. So what times 1/2 gets me 6? I'm going to go with 12. So 12 times 1/2 is 6H2 plus 6Cl2 reacts to form 12HCl. I'm going to cross this out, multiply this guy by 12. Negative 92.3 times 12 gives me negative 1007.6. Or 1107, sorry. Negative 1107.6. I'm going to cross that out. Alright. Now the 6H2 on the reactant side can cross out. That 6H2 on the product side. There's 12HCl, we want to have 6. Here we have 6 on the reactant side, 12 on the product side. So these 6 are going to cross out, but only 6 of these are going to cross out. So 12 minus 6 is 6 HCl. Now if we look at it, what's left on our reactant side? We got B2H6 plus Cl2, 6 of them. B2H6 plus 6Cl2. On the product side, we got 2BCl3 plus 6HCl. 2BCl3 plus 6HCl. So it looks like it works out. We flipped it, multiplied by the numbers that we needed to do in order for things to cancel out, so that this basically summarizes all these together will equal this equation. So then, according to Hess's law, we can add up the changed delta H's to find our total delta H for this summary equation. Alright. So, negative 1107.6, we're going to add that negative 493.4. And we're going to add 225. Gives us negative 1376 kilojoules is our delta H. That is how you do a Hess's law problem.